Hello, everybody. This is the first lesson in Unit 7 in meteorology. And in today's video, I'm going to be going over station models. We'll go over how we get data to put into a station model, how we input the data into a station model, and how we can read a station model and interpret the data that's being shown there. So here in New York City, one of the most famous weather stations around was put up right here in Belvedere Castle in the middle of Central Park in 1920. So about 100 years of weather forecasting from this weather station. All the way at the top of this tower, you'll see a number of instruments like a thermometer to give us the temperature, a barometer to get the atmospheric pressure, an anemometer to get the wind speed, a wind vane to get the wind direction, and a number of other instruments to get weather data of what's currently happening. Since that past setup, if you go a little bit south, you'll see a little bit of an upgrade with some new technology, but still all of this data is going to be collected here at the weather station, and then it's going to be represented in this kind of symbol called a station model. Now in the Earth Science Reference Tables in your ESRT, it actually gives us an explanation of the station model. So I'll be going over all these variables and how to interpret some of the trickier parts. So first off, pay attention to what units are used in the station model. So you'll notice that in the top left, we have temperature and it's represented in degrees Fahrenheit. The dew point here on the bottom left is in degrees Fahrenheit. The precipitation is the inches in the past 6 hours. So pay attention to the unit that's in the parentheses. On the bottom, it will show us the present weather. To the left of this circle here, it'll show us with a symbol of what's happening. And I'm going to go into a little bit more detail of how to get the cloud cover is how much of the circle is shaded in. I'm going to go into more detail for the wind speed and direction and the barometric pressure, just because there is a little bit of calculating, a little bit of adjustments that you'll have to make in order to get that data. So for the wind, you'll notice that there is a staff coming off of the circle, and it's coming off of the circle in the direction that the wind is blowing from. So if you look at this explanation, remember it's in the parentheses, it's saying it's from the southwest, because this is north, south, east, west. So if this is in between south and east, or south and west, we would say that the wind is blowing from the southwest. So that's the direction that the staff is coming off. Now, at the end of the staff, we have these things called feathers. And I'll have to stop moving my mouse so that that box goes away. So you'll notice that the whole feather, or the longer line, is going to be worth 10 knots of speed or velocity. And the half feather is going to be worth 5 knots of velocity. So in order to get the total velocity, you just add up the amount of feathers that are on the staff. So if we were to get some explanation in these two, for station model A, I see that the staff is coming off the bottom of the circle. So again, it's north, south. So the direction would be from the south. And since I have a half staff coming off, or a half feather coming off that staff, I would say it's 5 knots. For B, I have the staff coming in this direction, so north, south, east, west. The wind is blowing from the northwest at a velocity of, I'm going to add them all up, 10 plus 10 plus 5, we would get 25 knots from the northwest. So that's how you figure out wind, speed, and direction. The next thing I'm going to go over, which is definitely a little bit trickier, is figuring out the barometric pressure. So there's a number of different ways I've taught students how to work with this abbreviation. So the atmospheric pressure is abbreviated in millibars. So here it says 196, but it actually means 1019.6. And that's because they take the 10 or the 9 off of the front of the number and they lose the decimal place. So in order to interpret that number, we have to go the opposite way. We're going to take these 3 digits and we're going to add either a 9 or a 10, depending on the value. And then we'll add a decimal in between the last 2 values. So usually that will get us a number that's right around 1,000. So you can even do like a guess and check. So you can try it with 9. Is it close to 1,000? If it is, then you can be confident that you got it right. If it doesn't look right, try it with a 10. We're going to practice with some of these barometric pressure abbreviations right now. All right, so let's start practicing with this rule. So we're going to pretend that instead of 196, we get one of these 3 numbers in the top right of our station model. And we're going to use this rule to determine the true barometric pressure in an area. So since this number is 074, it's in between 000 and 499. So I'm going to add a 10. Where are my little drawing utensils here? So I take the 074. I'm going to add a 10 to the front of that number. And then I'll add the decimal in between the last 2. So I get 1007.4, and the unit is millibars. If 903 is here in the top right, first we could just write the number in, 903. Now it's in between 500 and 999, so this time around I will add a 9. And again, I add a decimal in between the last 2. Remember, these are all pretty close to 1,000, right? 990, 1,007. We're getting right around that average barometric pressure of 1,013. Let's take a look at this next one. I'm going to go 004. First, I'll just write the abbreviation in. In between 0 and 499, I'll add my 10 to the front of it. And then I put a little decimal in there. One more. If I see the number 827 up there, I copy the number down, 827. It's in between 500 and 999, so I'll add a 9, and then I add my decimal point. That is usually the trickier part of working with station models, so just kind of put that on your radar.